All right. So we covered some basic introduction of the course in the last two lectures. Um, so this is the grading policy. There is no end sum exam. There is a project instead of end sum exam. Assignments are 20%. Those are individual assignments. Minor one, minor two, 20% each. And end sum term project is 40%. That will be a group project. Okay. And I won't get into details of this because I already spent quite some time on this. So my recordings and course lectures are available. If you want, the TS can share with you. Okay, so basically AR, VR, and also MR. We looked at that. AR is augmented reality, where you overlay some digital content or virtual content over some real content. So whatever you see through a camera, phone camera, that is real content, and you overlay some digital or virtual content. It can be some text or some image or some 3D object. You overlay something virtual over that, so that it enhances, or it can be for information, or it can enhance your experience, or in whatever way. So these are some examples that we saw. Pokemon Go, you all know, that's an example of AR, VR. I mean AR, augmented reality. You are sort of overlaying a virtual object in real space. Okay, and Snapchat filters, which you all know, that is also example of AR. You are overlaying some virtual elements over your face or whatever. And virtual furniture placement, say you want to buy some furniture, you want to see how it looks in your room, so you want to see before buying it to get the feel of it, right? That is another example of AR. So basically augmenting in general in English means to add, to sort of supplement, or to add on top of something, to add to something. So augmented reality means you have your reality as it is, you are adding something in addition to that. That's all. So what you're adding is virtual. Okay. So AR, what we are doing, we have reality as it is, we have our sensory field, we are placing some virtual content in our sensory field. So that is AR. Okay. And AR measurement, say instead of using a tape, you can use your phone to measure some space. You can just point your camera, move it from point A to point B, it will give you the length, and it will overlay that length on your camera screen, on your phone screen. That's it, as simple as that, right? And head-up display, say for pilots, or even in some cars now, head-up display is there, where you need not turn your head to see some statistics. At the same time, it is not obstructing your vision. Okay, so something is augmented on your glass or screen. Okay, so these are all some examples of AR. And I showed a video of indoor navigation, like imagine you are in a supermarket, you want to search for an item, you are anywhere, you can be anywhere in the supermarket. From your current position, it will show you the path to go to that item. So that path is virtual, that path is augmented over the phone screen. That is another example of augmented reality, and it has many use cases, like if you want to search something in a mall, you can use this application, or if you want to search something in a campus as large as ours, you can have such an application. So that has many use cases. Okay, I showed that video, it's in one of my previous lectures. More applications for education, object recognition. Education in the sense, say if you have a textbook, say a student is reading about some experiment. Right now in the textbook there is only some image of the textbook, but a student cannot visualize with that image alone. So you can overlay some 3D animation while the student is looking at the textbook page through a phone screen, or you can overlay a video playing, you can overlay an image or anything. So the knowledge or the learning is enhanced by that. Okay, and object recognition, this is like Google Lens. You point at an object and it gives you some information about that object. Right now what Google Lens does is it takes you to a different page, or it gives you the Google search results. But we don't want to go to another web page. We want the summary about that object being overlaid right there on my screen. the virtual information overlaid right there on my screen. Okay, and similarly, looking at museum object or a monument and overlaying its historical information over it. So when you are looking at a museum, walking through a museum, and each object has a lot of information. All that information can't be put beside that object. So, but if you look at it through your screen, it can overlay some information. It should detect that object and overlay that information on that screen, on our screen. And recreating or reenacting some monument or event from the past at a given site. Again, say you visit a war site, something happened in the remote past, but you want to visualize how it looked. So you just point your screen there, and then whatever events happened in the past, those are sort of overlaid on your screen. Okay, or some incomplete monuments are there. When you point your screen there, it is completing the rest of the monument. Okay, and scanning a clothing item's barcode and it's showing us the pictures of some celebrities or models wearing it to give us an idea of how it looks when one wears them. Again, one is online shopping, where you actually see some models wearing that particular clothing item which you are shopping. But say if you are in a store and you want to see how it looks on a model or some celebrity, then you just scan it and it brings the picture of the model or someone who is wearing it. Another thing is, you want to know how it looks on you, right? It may look good on someone else, but you want to know how it looks on you. That is a more complex thing, because it should sort of scan your body, understand your measurements, understand the structure of your body, and then overlay this cloth according to that structure, not just to any body. It's not like it just fits your face on any regular body. It should understand your body and then tell you whether it looks good on you or not, right? So that is another thing that's more complex. So many applications, not only these, you can think of umpteen number of applications which are not even listed here. So many applications are there of AR. Basically, whenever you can add some content which will enhance the user experience or enhance the user's knowledge, that will be a very useful application for anyone. Okay. All right. So now, in all these examples that we saw, there are two things happening. Like if you say, look at this example of, say, education, where a student is looking at a textbook and some experiment is being described there. It can be, or not even an experiment, say solar system. Solar system is being described there. Now, your app should automatically recognize what is the experiment or the topic that is in the textbook page, and it should overlay the relevant information. It can be relevant textual information or visual information. So there are two things. One is the input. It is getting the input from the textbook page. Now it should analyze that input, recognize what is the content in the textbook page, right? So different kinds of recognitions are there. In this case, it is textual recognition. And then analysis of that. What is this text describing? What is being discussed in this textbook page, right? Or sometimes you analyze not just the text but also the image. Say if there is an image of solar system on the textbook page, then you need to recognize that image and understand what image is there, right? This is image recognition. Or maybe facial recognition, all kinds of recognitions. Basically, you need to recognize the content from your camera input. Okay, this is the first step. Once you do that, then you decide what content to overlay there. If it is solar system content, I will overlay a 3D simulation of solar system, 3D model of solar system. If it is maybe some chemical experiment, I will overlay a 3D simulation of chemical experiment. If it is maybe a pulley system, I will overlay 3D model of pulley system. So depending on the input, I change my output, right? So the first part is you recognize what you are looking at. You analyze, you recognize what you are looking at, right? That requires computer vision. All right. So whatever algorithms which you would have heard of, like YOLO, object recognition, face recognition, all these algorithms, they basically use computer vision. You would have used this library OpenCV. CV is what? Computer vision. So OpenCV library is a suite of CV algorithms and CV technologies. So it allows you to, recognize objects in the frame, in the image, in the video, or to track them, or to even slightly modify the image, to filter it, to make it monochrome, or do various things, right? All these are computer vision technologies. So you are doing that. So once you recognize, what do you want to do? Now you want to overlay some information. It can be text, it can be image, it can be 3D object, it can be audio, whatever it is, you can overlay different kinds of information. Now where does this information come from? This information is not there in reality. Like Pokemon Go. Where does the Pokemon character come from? It's not there in reality. Someone has to create that, right? This doesn't come from computer vision. It's not analysis. It is synthesis. You are building it. Someone is building it, right? So this building happens using computer graphics technology. Computer graphics, it's not like only, large movies and all that where they use graphics. Only that is not computer graphics. A very basic thing, something as simple as a window coming up on your screen, or text being displayed on your screen, or when you're typing the text coming up on your screen. Any simple thing that is coming up on your screen, it can be an image, it can be text, it can be a window, it can be 3D graphics, it can be high-end graphics, it can be the video games that you're playing, or it can be a YouTube video, whatever it is, everything is using computer graphics. Because every step you are actually rendering something. Rendering means projecting some colors onto the screen. So any projection of colors onto the screen is computer graphics. Depending on the application, it becomes more and more complex. If it is plain textual editor, you don't need so much high-end graphics. If you need slightly an image, slightly advanced graphics. If you need a video, slightly advanced graphics. If you need 3D rendering, more advanced graphics. That's all. But everything is graphics. It is generating everything from scratch. Okay, so Pokemon Go character needs to be generated or created by someone. How do they do that? They do it using computer graphics. Or high-end graphics which you see in video games, they are created using computer graphics. A video which you are playing, that is also created using computer graphics. Okay, so these two steps are important for AR. In AR, what are we doing? Augmented reality. So imagine two words, augmented and reality. First, you need to recognize reality out there. Whatever reality you're seeing, you need to recognize that. For that, what do you use? Computer vision. And then you augment something over it. You add something over it. For that, what do you use? Computer graphics. Okay. So these two steps are important for AR. For VR, what do you need? Virtual reality? Just computer graphics. There is no reality out there. You are creating some entirely fictional thing. It's like a video game you're creating from scratch, or something you're creating from scratch. For that, you don't need any reality out there. So because it is completely virtual, you are creating just using computer graphics. You don't need computer vision there. Okay, so that is the difference. Fine? Yeah. So far we looked at AR. AR requires these two steps. You need to analyze the content and then overlay some content. For analysis, you need computer vision, and for overlaying, you need computer graphics. Okay? And then virtual reality. Virtual reality, as you all know. So in virtual reality, what are we doing? The entire basically you are completely transported into a different world. Okay, you are immersed into a different world. In augmented reality, we are not transported to a different world. We are in our world wherever we are. We are just overlaying some virtual content into our world. So we are sort of bringing virtual content into our world. But in virtual reality, we are completely transported into some other world. Okay, so that is more immersive. Virtual reality is more immersive. And again, I showed a couple of videos last time, a video last time. I won't play it. It's again in my video recording that I shared. So basically there are some games, some VR games where say you are afraid of heights. You are taken to a very tall building, and rather than asking you to imagine being at a tall building, being on top of a tall building, you are actually given that experience. That experience is actually simulated for you, right? Just by wearing a headset, just by changing your surroundings, the visual surroundings and the sounds, all these things around you, you actually believe that you are on top of that building. Okay, so our senses actually trick us. Although our logic knows, logically we know that we are not there, but our experience overpowers our logic so much so that we can't. So much so that we start believing that we are there. So we undergo all those experiences. It can be fear, it can be happiness, it can be shock. All these things, we undergo all those feelings because of the depth of this immersiveness, because we are immersed into that. Right now, most of the VR headsets that are there, they sort of simulate only the visual and auditory senses. But as the technology advances, more senses are sort of captured by VR, like our touch, our smell, our taste. Even these can be captured. Then it will be like we are completely in that environment. We won't really understand whether we are in a real world or a dream world. I gave this example last time. Whenever you are in a dream, as long as you are in a dream, you believe that that is your reality. You don't know that you are in a dream, right? Only when you wake up that you realize you were in a dream. But as long as you are in a dream, you don't know that it is a dream. It is real for you. Similarly, right now when we wear a VR headset, we sort of know that it is virtual because our other senses, like even when I wear a headset, when I move around, I may touch some other object which is different from what I'm seeing. So that will sort of give me a feedback that okay, I am still in my real world. This is only virtual world. But imagine all your senses are hijacked, and then you are put in this virtual world. Maybe after some time you can't distinguish between real world and virtual world. This is real for you. Everything is as it is. I mean, the images, the visuals which you are getting, they don't look cartoonish anymore. They don't look virtual anymore. They also look extremely real. The lighting, the colors, everything. They look extremely real. The sounds are real. The tactile sensation is real. Smell, taste, everything is happening. So it's like that is reality for you, right? So virtual reality that's why used in many applications. It's like gaming. Anyway, we know all kinds of VR games are there, and healthcare, particularly for in psychotherapy, they use VR headsets quite a lot, like for pain management or rehabilitation, to change your habits, or therapy. Like I just mentioned, say if you're scared of heights, rather than asking you to sit here and imagine you are at some height and then try to overcome your fear or observe what is happening inside you, none of that. You just wear a VR headset and you are actually transported there. Now whatever exercises are there, they are suggested for you. Either observe your breath, observe your feelings, observe your thoughts, all those things, and then slowly try walking over the plank which is extended outside the building, all those things. So it is safe, at the same time it is very real, right? So that's a very sweet combination, right? So VR is used in those cases. And virtual tourism, like I can sit here and I can visit Taj Mahal, or I can visit Eiffel Tower, or anything I want. It will be as real to me as if I am there, right? And again, aviation, medicine, military training, etc., in all these cases also VR headsets are used. All right. So what is the difference between AR and VR? While AR places digital or virtual objects in our sensory field, VR places our sensory field itself in a virtual or digital world. So that is the difference. In AR, the virtual content is only an addition. That is not the main thing. Whereas in VR, the virtual content is the main thing. And there is no iota of any reality, our own physical reality. Okay, so this is the contrast. So our sensory field, whatever is there, if you place some virtual object in it, that is AR. But if you transport our entire sensory field into some other reality, into virtual world, that is VR. Right now, our entire sensory field is not transported. Our visual and auditory senses are transported, but more and more senses can also be captured and transported to virtual world. Okay, so that becomes VR. That's like truly immersive VR. All right. And mixed reality. Mixed reality is any portion of mixing of AR with VR. VR, purely VR, like I said, when you wear a headset, you're completely cut off from your actual reality, right? And AR, you are anyway, you know you are completely in your reality, and some virtual content is being overlaid there, okay? But mixed reality, it's like one is mixing of AR and VR. Second important thing is interactivity. Like you are able to interact with the virtual content now by being in reality. So a simple example is, okay, where is that slide? I think, okay, a simple example is like, in Iron Man movie, he projects, Jarvis, and he projects hologram onto the table or whatever it is. He plays with that. Yeah, holographic projections. So that is like a very, futuristic thing where he's not wearing any headset or any such thing, but he is able to interact with the purely digital content. That is not at all real, that is digital. And it's not just passive, it is active. He is able to interact with it. It is responding to his actions. He is picking up something, it is moving. He is rotating something, it is rotating, right? All these things are happening. And he is doing it in a very natural way. He is not using any equipment per se. So that's like very ideal or futuristic scenario. Right now what we have MR headsets. We have mixed reality headsets like Microsoft HoloLens or Apple Vision Pro, which is going to be released, or already some pieces are released. So there it is like something is being projected onto your reality. Now imagine you are wearing that headset and the same thing is happening. You see some kind of a hologram in front of you and you're trying to touch it, you're trying to scale it, you're trying to rotate it. All these things are happening just through your actions. Why? It is projecting that hologram onto you. At the same time, it is recognizing your hand gestures. It is recognizing your hand movements, and it is interactive. Yeah, and it is translating those hand movements into digital actions. So it is to and fro, right? Whereas normally in augmented reality, whatever virtual content is there, it's just there. It's say like when a student is looking at some textbook, some simulation is overlaid there. That's it. The student cannot do anything else except watching that, right? There is no interactivity there. But if one can interact with it, or even if one interacts, it is through the screen. I play it, pause it, stop it, or zoom it, or remove it, whatever it is through the screen. But suppose it seems to me as if my phone is here, textbook is here, and the simulation is somewhere in between. If I am able to sort of control that simulation by doing my hand gestures here, that is mixed reality, right? Not here. I am doing something, I am saying scale it, or move it, or rotate it. I am doing some hand gestures here, and my phone camera is recognizing that, and it is changing the content which is displayed here. Okay, so that is mixed reality. Or another simple example is again like Snapchat filters. Whatever you see on your face, it can be mustache or horns or ears or whatever, you can't really interact with them. Or even if you do, you have to do it through the screen. But suppose if I put my hand like this and I want to remove my horn or ear or change my mustache, remove it, or do something like that, it should recognize my hand gestures and then react accordingly. That is mixed reality. Okay, so my physical actions in the physical world affect the virtual object. It is not like my actions in the digital world affect the virtual object. Okay, my physical actions in a very natural way in the physical world affect the virtual object, and back and forth, if that is possible. That is mixed reality, right? Or again like Apple Vision Pro and even Microsoft HoloLens, they do some things like, say, they project a screen. When you wear the headset, they project a screen in front of you in the midair, and you can sort of now control that screen in a very natural way. Like suppose it's a browser, I can scroll it like this, or I can click a button there, or I can close it, I can swipe it, zoom it. All these things I can do through my hand gestures, and it recognizes them and it changes the browser page accordingly. Okay, I'm not touching my headset, I am not pressing buttons on my headset, I am doing it naturally. It looks as if it is there, and I am behaving as if it is there, and it is accepting that behavior. It is reacting or responding to that behavior, right? That is the difference. Whereas in the phone camera scenario, it is looking as if it is here, but it is not taking my behavior when I behave it as if it is here. It is looking here, but it is taking my behavior here. Okay, so there is a slight, so it is not exactly mixed reality, right? So one is interactivity. Again, you see, sometimes you cannot exactly say this is mixed reality or not. There is a scale, there is a gradation. It is more mixed reality, or much more mixed reality, something like that. Like wearing a headset is, yes, mixed reality. But without wearing headset and doing something like what Iron Man does is much more advanced mixed reality, right? So it's a gradation, all right? So this gradation is what we call as reality virtuality continuum. Okay, so the more and more virtual it becomes. Okay, this side is reality, this side is virtuality. In between you have mixed reality. So any mixture of AR and VR in any proportion is mixed reality. But again, more and more mixed reality or more advanced mixed reality, that is that's a gradation. That's all. Okay, and this reality virtuality continuum can also be called XR or extended reality. This entire thing can also be called XR. Again, mixed reality applications, education and training, healthcare, many more things. I discussed some of them in the previous lecture. I won't again spend time. And extended reality is an umbrella term that encompasses all forms of reality technology, including augmented reality, virtual reality, and mixed reality. It refers to the spectrum of experiences that merge the real and virtual worlds. So there are two ways of looking XR. One is this entire range, reality virtuality continuum, can be called XR because it is extended reality. Okay. Another way of looking at it is the X in XR is a variable. It can mean AR, VR, or MR, right? So XR may refer to any of AR, VR, or MR. So when we say XR technologies, it can mean anything. AR technology, VR tech, or MR, or anything. Okay, so that's another meaning of XR. Fine. All right. So now just let me add. So now that we discussed the concepts of AR, VR, MR, now we will look at the tools for XR development. Okay, so how do we implement these technologies, or how do we build these applications, right? So that's the next question. Okay, so let's start with AR. Tools means we need both. We need hardware, we need software. Okay, for each of these. For AR, we need hardware, software. For VR, for MR, we need different kinds of hardware and software. For AR, the most simplistic, AR is the only one with the most easily accessible technology, that is our mobile phones. You just need a mobile phone to implement an AR application, or a tablet. Mobile phone, tablet, any of these are sufficient. Smart glasses are more advanced. Okay, so just having a phone will help you to build an entire AR application, because most of the examples that we saw, it can be Pokemon Go, it can be virtual furniture placement, it can be education apps, or it can be say when you or object recognition. When you look at an object, some information is overlaid on that, or when you're going through a museum, you point your phone there and something is popped up on your camera's phone screen. All these things, you just need a mobile phone. Okay, so AR, you don't need very fancy hardware. Mobile phone is enough, or even a digital tablet is enough. Smart glasses, they're more advanced, but smart glasses are more like AR rather than VR or MR, because you're not really interacting with that. It's just overlaying some augmented information on you. Say you are walking through some street and it is telling you what street it is, or maybe you did a Google search to go to some place. It is overlaying the directions on your glasses. Go straight, go right, or whatever. Or it is sort of overlaying some digital information. Okay, this is a coffee shop. when you're looking at a building, it says this is a coffee shop, or this is a restaurant, or this is a hotel, or this is a specific monument. That information is being overlaid on your visual input. You're looking at the building, at the same time the digital pop-up is coming saying what kind of monument you're looking at, what kind of building you're looking at. Okay, so it's just basically augmentation. You're not really interacting with that. You are in your reality, you are looking at real things. Some additional information is being augmented. Rather than pointing a phone screen and holding it with your hand, you're just wearing smart glasses and it is overlaid on your smart glasses. As simple as that. Okay, so this is the basic hardware for AR. For VR, we need headsets because it should be immersive. And for it to be immersive, you have to be cut off from your external surroundings. For you to be cut off from your external surroundings, it has to cover your eyes completely. Okay? And if possible, your ears also. You should not get any surrounding sounds, only the virtual sounds you should get. Okay? So headsets, we know, these are just a couple of headsets. There are many other headsets. These are popular. Oculus, Meta Oculus Quest we know, and PlayStation VR. These we know anyway. And headsets for MR, mixed reality. Apple Vision Pro and Microsoft HoloLens. And there are many more headsets. Two others are again very popular, Vario XR and Magic Leap. They also provide very realistic experiences. Okay, not only experiences, but they also have some applications where you can sort of interact with the digital content or the virtual content through your gestures. Okay, so you see, all the big companies are into this field. I mean, Meta, you already know, Facebook has renamed itself as Meta because it is into metaverse. Metaverse includes all these things, AR, VR, MR, all these things. And now Apple has also entered with its MR headset, mixed reality headset. So you just imagine how much potential is there for this field. Like all the big players are jumping in. Okay, so there is a lot of scope to do a lot of things, and it's sky is the limit. Only your imagination is the limit. Whatever use cases you want to build. Right now it's a niche area, or right now it's still in infancy. Although these terms have been there for long, you don't really find useful applications yet. Maybe VR headsets for games are there to some level, but AR as such, or mixed reality also, is still in nascent stages. So you have a lot of scope to do, a lot of things. You can be one of the first people who is working on these things. Okay, so you have that advantage to begin early. Yeah, and all right. So now softwares. Okay, we need these tools. We need some hardware for AR, hardware for VR, hardware for MR. What about the softwares? What softwares to use, right? So two main softwares are Unity and Unreal. Basically, Unity and Unreal are actually game engines. They began with the idea to provide some platform or provide some software to develop games. Okay, more and more advanced games, the 3D games, all the big game names that you hear, they are all mostly developed using Unity or Unreal. Okay. Now, I mean, just a few years back, not very few, maybe 10 years or more, AR is also sort of being integrated with Unity and Unreal. Games are completely VR, right? In the last class I mentioned, they become VR when you wear a headset. Okay, otherwise they're just virtual. Virtual and virtual reality, what is the difference? Whatever you're seeing on TV, whatever you're seeing on laptop screen, they're all virtual, but they don't become virtual reality. They become virtual reality when you're immersed in them. When you wear a headset, or when you're completely transported to that game world, to that game environment, then it becomes virtual reality for you. Okay, so games are virtual, and giving this VR access to that is not very difficult, but they're actually virtual. There's nothing augmented or AR about them. Okay, but there are other applications which, when combined with these engines, help you to build AR applications. Okay, so you can build games, And also you can build AR applications. You can build VR as well as AR applications using Unity, Unreal. Lens Studio is of Snapchat. That is Snapchat's software tool to develop AR applications. Okay, so whatever you see, Snapchat filters and all that, they are developed using Lens Studio. All right, and Spark AR Studio, does anyone know? Sorry? Who developed that? It is of Facebook. It is of Meta. So Insta filters and Facebook filters or whatever filters you see on Meta owned platforms, those are developed using Spark AR. And Spark AR Studio is the tool which is used to develop them. Okay, so these are some very famous tools. The first two can develop both VR and AR. They can develop complete games also. The later two is mostly for AR, right? Because Snapchat and Facebook, mostly AR applications you develop using them. Yeah, so whatever I present in the last slide, same things described here. So Unity is a popular game development platform that supports XR development. Again, anything, AR, VR, MR, all this, it helps. Unreal Engine, again a powerful tool for creating immersive XR experiences developed by Epic Games. This you would have heard, Epic Games. Many of the big games that you play, they were developed by Epic Games company. Spark AR Studio, it allows users to design and build AR effects, filters and interactive experiences that can be used on various Facebook-owned platforms, including Instagram, Facebook and Messenger. Lens Studio, it is a free desktop application developed by Snap Inc. that allows users to create AR lenses filters for Snapchat. Okay, so these are different tools to develop AR and VR applications. And then we have SDKs or software development kits, which are platform specific. So what is the difference between a development engine and an SDK? A development engine is a standalone thing. It comes with everything it requires. It has interface, it has tools, it has libraries. You can work on that just by using that. Okay, but in case you want to enhance its features or add some additional features, you can install some plugins, right? It's like imagine a browser and its extensions. Browser is a standalone thing, whereas extensions are like plugins. Some additional features you want to install, you want to use. So those you use through plugins. Okay, SDKs are not as simple as plugins. They are slightly more advanced. They are a very large suite of packages, the very large suite of libraries, functions, commands, all these things put together in some package. Now, to use this package, there is no interface. You cannot directly access this package. You need to use some other interface to access this package. It can be a development engine like Unity or Unreal, or it can be your pure code. It's like API. Imagine you have APIs. How do you access APIs? There is no interface for that. You sort of import those APIs into your code, right? So these SDKs are like a huge bundle of APIs. Lot of functions, lot of libraries and all those things. So you sort of import them into some development engine, or you write a code which accesses these APIs and performs or executes the functions from these SDKs. Okay, so we have SDKs which are platform specific and we have SDKs which are platform independent. Platform specific SDKs, two are important. For iOS, you have ARKit. For Google or Android, you have ARCode. Okay, so ARKit is a huge library of functions and APIs. To use that, you need to integrate it with either Unity. I mean, not integrate exactly. We will come to that. You're not actually integrating that. You transport your Unity code into ARKit and then you run that ARKit code again in iOS or Mac OS to build an iOS app. I mean, we will see that later. But ARKit is specific to Apple and ARCore is specific to Google. Okay, and then there are SDKs which are cross-platform. Two main ones. So you see in all these slides, whatever hardware, software which I am presenting to you, they are not all of them. There are many others, but these are popular and these are widely used. Okay. For cross-platform SDKs, Vuforia is a very popular one. It has been there for more than 10 years. So Unity by itself, as I said, it is a game engine. It by itself does not develop AR applications, or you can't develop AR applications using Unity, plain vanilla Unity. You have to integrate some other external package which allows you to build AR applications. So one such popular external package is Vuforia. Okay, it's an SDK which can be integrated into Unity as a plugin and allows you to develop AR applications. So Vuforia plus Unity allows you to develop AR applications. Okay. Later, Unity themselves developed a new SDK called AR Foundation. Okay, and that integrates only with Unity. Vuforia can integrate with Unity as well as Unreal. Okay, so it is cross-platform, and using this Unity plus Vuforia or Unreal plus Vuforia, you can develop both iOS AR apps as well as Android AR apps. Whereas using ARKit, you can develop only iOS apps. Using ARCore, you can develop only Android apps. But if you use Unity or Unreal, you can develop both platforms, apps for both the platforms. But Unity and Unreal themselves cannot build AR applications, so you need to use these SDKs. Vuforia can be used both for Unity and Unreal, but Unity AR Foundation can be used only for Unity. Okay? Yeah. Yeah, so whatever I listed here, ARCore is Google's platform for building augmented reality apps for Android devices. ARKit is Apple's framework for developing AR apps for iOS devices. Okay, I think AR Foundation is also, I'm not sure. Is it only for Unity or for Unity and Unreal?
It was developed by Unity, sir,
maybe. We just need to check that. That I am not sure if they developed it to be independent of Unity or to be integrated only with Unity, but it is developed by Unity. But whatever it is, using Vuforia and AR Foundation, you can develop Android apps as well as iOS apps. In that sense, it is cross-platform. Okay? Yeah, Vuforia provides plugins to integrate with Unity and Unreal. AR Foundation is developed by Unity specifically to enable developers to create cross-platform AR experiences with a single code base. It is only for Unity, not Unreal. Yeah. There are more SDKs which are device specific. I mean, like we have hardware, some of the hardware which we saw earlier, like Microsoft HoloLens is one, Oculus is one, right? They have their own SDKs. So you can build apps specific to Microsoft HoloLens. You can build apps specific to Oculus, right? For which you need to use their SDKs. So for Microsoft HoloLens, you have something called Windows Mixed Reality Toolkit. It encompasses a range of immersive technologies and hardware devices that allow users to interact with a blend of digital content in the real world. The platform was introduced by Microsoft as part of the Windows 10 operating system. And then Oculus SDK, it's a set of tools, libraries, and documentation provided for developers to create VR applications and experiences for Oculus VR devices. Okay, so these are two more SDKs which are device specific. All right. And then what programming languages should we use? Again, they vary from application to application and device to device and engine to engine. If you are using Unity or Vuforia and AR Foundation, then the primary language is C#. It is not C#, it is C#. Okay. And if you are using Unreal Engine, then C++. And if you are using Spark AR or Lens Studio, it is JavaScript. And for Android development with ARCore, it is Java. And then you later have Kotlin, other related things. And for ARKit, it is Swift. Anything you want to build on Apple, it is Swift. Okay. So in this course, initially I thought we will start with ARKit, but later I felt that it is better to start with Unity. We will start with Unity because Unity is cross-platform and you can develop both iOS apps and Android apps using that, and its learning curve is slightly less steep compared to ARKit and Swift. Okay, C# is easier, Unity is easier compared to ARKit and Swift, and also it can be used for cross platforms. So we will start with Unity, we will spend sufficient time on that, and ARKit we will, if you are interested, you can build some app or whatever, you can learn it on your own. We will give you the directions and you can build something on ARKit. Okay, so we will focus on Unity and C# in this course, and if time permits on ARKit as well. All right, now so we saw that we need one, recognition, computer vision, and computer graphics for AR. For VR, only computer graphics are sufficient. So in both these cases, at least computer graphics are sufficient. So we'll actually start with VR rather than AR, because that component is anyway common for both VR and AR. So it's like you can develop some game on your own. Is there a class? So you can develop some game, it can be 2D game, 3D game, whatever it is, independent of AR, independent of overlaying something. You can just develop a game, virtual game, with whatever VR knowledge that you get. Okay. Now for that, one is, when you develop a game, what do? You need to create a lot of objects, right? A lot of objects in the sense, any game you take, it can be Mario, it can be car racing game, or it can be anything. You need to create all those 3D objects. It can be 2D game, then there are 2D objects. It can be 3D game, then you need to create 3D objects. So one is, where do you get these 3D objects from, right? Either you create them from scratch, or you use some existing 3D objects and import them into your environment. I may create some 3D objects which are unique to my game, but why do I need to create every 3D object from scratch? Suppose if I want to create some simple trees or buildings, why do I need to create them from scratch? I can use existing ones, right? So I can import existing 3D objects and incorporate them in my game, or if I want to build something on my own, I can do that as well. This is necessary not only for VR applications, not only for games, but also even for AR. Suppose I want to create a solar system. I want to create a particular sphere or a particular ellipse, or if not solar system, say I want to create some 3D simulation, maybe of a car game. My thing is just to tell the student how a physics experiment works. Say when a car is on an inclined plane, how fast it goes, or when it collides something, what happens. For this, I need not sit and create a car from scratch. I can just use some existing car and do animations on that, right? Write a code for that. So even in AR or in VR, you have both you need objects. Okay, you need objects for your graphics. For when you're overlaying graphics also you need objects, or when you are creating an entire game you need graphics, you need objects. Okay, now there are two ways of getting these objects. One is you import objects from existing sources and use them in your scene or environment. Second is, if you don't find them elsewhere, you create them from scratch. So we have environments, or we have tools for this as well. So first is, you have something called asset libraries, 3D asset libraries. These are just two popular ones. Again, you have many. I just didn't list all of them. You have many. Sketchfab is a very popular one. You can import different kinds of 3D objects from online into your scene. Some are free, some are paid. But there are very good collection. In fact, it is constantly being updated. Someone creates a 3D object, uploads it there, right? So you can import them into your scene or environment, as well as Unity Asset Store itself has a huge library of 3D assets, right? And these objects, don't think a 3D object is just some passive object which comes and sits there. 3D object will also require a lot of animations, right? It can be a human moving, running, or jumping. All these are animations which come with the 3D object. So you can import these objects along with the animations. Okay? Is there a class? No? Okay. So animations, so you can import them along with the animations. So it's a huge complex thing. You can import them or you can build them on your own, and or if you want to create them from scratch, again you have multiple tools, multiple platforms. Blender is a very popular one, and Maya is another very popular one. Autodesk is actually a suite of tools, of which Maya is one, and you would have heard of AutoCAD, which is mainly used for architecture, right? That is another one, and 3ds Max is also of Autodesk, and SketchUp is a different one. So many more tools you have. You can create them from scratch. Actually, you see, that's what creating an AR application or a VR application is not a one man's job or one person's job. There are many things. You need a designer, or creating a game. You need a story, someone who creates the story, and then someone who creates the graphics, someone who creates the 3D objects, someone who writes the code. All these things are necessary to build a game. Similarly for AR. Now in AR, you need someone who does computer vision, right? All these things. So learning each of them itself is a course in itself. To learn Blender itself, it's a course. Again, to learn Unity, that's a course. To learn ARKit, that's a course. So each of these are very huge things to learn, to explore. But that's why we will start with Unity, so that at least you will understand Unity in depth to some extent, and you will be able to use some existing tools to create something. If you have to learn them, again you have to learn them separately. If you have to learn Blender, you have to learn separately. But at least you can import some existing 3D objects, how to import them into your Unity game or Vuforia, and then how to create an AR app, all those things. In AR case, more than learning the tool, you need to understand the technology. Like what is happening, what is the mathematics behind it, right? In VR also you need to learn the mathematics a lot, because what is happening, it's all one huge coordinate system. You have origin, you are placing objects somewhere, you are creating animations, you are performing transformations, all these things you are doing. So even in that case, you need to learn mathematics. So we will touch those topics as well. All right, but what we will do, we will start with before delving into any concepts as such, we will start with some hands-on thing, some simple hands-on thing. We will start with Unity. We will try to understand its interface. We will try to just play around with it, so that later when we discuss the concepts, you will understand why we are discussing and in what context we are discussing those concepts, why these concepts are important and necessary. Okay, so that's what we will do. So before next lecture, what I want you people to do is, you please, I don't know why, just 2 minutes. You please install all these things. Unity Hub and Unity Editor. Unity Hub is nothing but it's like a hub for multiple versions of Unity. You can install multiple versions of Unity, 2020 version, 21 version, 22 version, all these things. Some things, some features are there in one version and not in the other version. And sometimes if you have a version problem, you try it in a different version. Okay. So in Unity Editor, you install 2021 version, not 2022 version, 2021 version. Okay, because there are some things which we want to discuss which are there only in 21 version. All right, and you also download 2 micro games. They are called micro games, 2D platformer micro game, and Lego micro game. There are other micro games also. We will see that, but right now these two, to introduce some concepts of Unity, these will be helpful. Actually, there is a site which you people sent me, right? So I will post that site link, and you just follow the steps in that site. You can do all these things easily. And in case you need any help, they will be available. So in the Discord group anyway, so all of you please join Discord group. So I'll post the link. I mean, right now it's better you take the link from them right now and join the Discord group, and whatever resources are there, I'll post on them, and also you can approach them through the Discord link or whatever. In case you face any hurdles in installation, they can help you. It's important that you install them before the next class, because it takes a lot of time. We can't install them in the class, and you come with your laptops in the next class. Okay, so we will do some hands-on thing. Fine? Yeah.
As you said, there are many components, right? In the project component, what deliverable are you expecting from us? Like which part of it?
Up to you. I'll give you many options. You have an option of building a simple game, or you have an option of building an AR app, or this within this itself. Again, there are many things. AR app or varieties of things, like many applications which we saw. Games can be of different kinds. It can be simple to very advanced, right? So what concepts you use, how complex your game is, all these things we will see. Basic idea is whether you learned how to build a game, at least one of these things, how to build a game or how to build an AR app or both. So that will be your project. Okay, that is the thing. All right, and whatever intermediate steps that you need finally to build a game, those will be given as assignments. Okay, either game or AR app, those will be given as assignments. Okay, so let me stop here.